Hello all the students. Today we are going to study the least upper bound and greatest lower bound in a poset. So what is a least upper bound and a greatest lower bound? Let's say we have a poset S, R such that S is an arbitrary set and R is a partial order defined on set S. So obviously a poset is denoted by S, R, where S is an arbitrary set and R is a partial order which is defined on that set S. So if we have such a poset, then also let us say that we have a set T which is a subset of set S. We have an arbitrary set S and then we have a set T which is a subset of the set S. In that case, what is a least upper bound? A least upper bound also denoted by the notation LUB. Let's say that U is the set of all upper bounds on set T. Now here we have a set T which is a subset of the set S. Then we have a set of all upper bounds on set T. That means U denotes all those elements which form the upper bound on set T. So basically U is the set of all the upper bounds on set T. Then an element X that belongs to set U. So we have taken an arbitrary element X that is an element of set U. In that case, X will be called the least upper bound if for all Y that belongs to set U. Now, X is one such arbitrary element which belongs to set U and Y here represents all those elements which belong to set U other than set X. X is one single element and Y represents all those remaining elements. So, X is one arbitrary element that exists in set U and Y is all those elements that exist in set U. So, in that case, if X, Y exists in the partial order R, or in other words, if X is related to all the remaining elements of the set U, in that case X will be called the least upper bound of the poset SR. Now let us see what is the greatest lower bound. Again, greatest lower bound is also denoted by GUB, which is the short form or notation for the greatest lower bound. Let us say now that we have a set L that represents this set of all lower bounds on set T. So basically set L consists of all those elements which form the lower bound on set T. Then an element X that exists in set L. So again X is one such arbitrary element that exists in the set L, and in that case X will be called the greatest upper bound if for all Y that exists in set L, that is for all the remaining elements other than X from set L, if all those Y are related to X, or in other words if the ordered pair Y, X exists in the partial order. That means all the remaining elements of the set L are related to that arbitrary element X. So in that case X will be called the greatest lower bound. Now here we will see an example. This is a hash diagram as you can see. So we will try to find out the greatest lower bound and the least upper bound from this hash diagram. Okay, so we have a problem given here which says that we have to find the greatest lower bound and the lowest upper bound of Bdg if they exist. So Bdg here is my subset T. So I have to find out the lower bound and the greatest lower bound and the lowest upper bound of the subset Bdg. Now it says that the upper bounds of Bdg are G and H. Now I have to concentrate at this portion Bdg. I am concentrating on this subset BD and G. For BD and G, if I look carefully, I will find out that G and H are the upper bounds of B, D and G, because B is related to G here, D is related to G here, and G is related to itself. Again, B is related to H here, D is related to H here, and G is also related to H here. So clearly G and H are the upper bounds of BDG. Now G is the lowest upper bound of BDG. Mind it, G and H are the upper bounds of BDG. Now out of these upper bounds, that means out of H and G, the lowest upper bound is G. Now why is G the lowest upper bound of BDG? Why not H? This is because G is related to H, but H is not related to G. So as per the definition of lowest upper bound, X must be related to all the elements of the subset, which is called the subset of the upper bound. So if the upper bound or the subset U is represented by G and H, then in that case G or H must be related to all the elements of the subset U. We can see that G is related to G and G is related to H. G is related to itself and G is related to H. But H is related to itself, H is related to itself, but H is not related to G. So as per the definition of the greatest lower bound, G is that arbitrary element which we represent as X, because G is related to all the elements of the set U, which is the set of upper bounds on this subset. So that means G is related to G, G is related to H, hence G is the lowest upper bound of subset BDG, which we were representing as the subset T, and the set and the elements G and H belong to the set U, which represents the set of upper bounds. So G is one such element which is related to all other elements of the upper bounds, set of upper bounds U. G is related to itself, G is related to H, but H is not related to G. So H cannot be that arbitrary element, but G is one such arbitrary element. So hence the greatest lower bound, the lowest upper bound of BDG is G. Okay, now let's look at the lower bounds. The lower bounds of BDG are those elements which are related to BD and G. Alright, so here I can clearly see that A and B are those two elements which are related to BD and G, hence I can call them the lower bounds of BDG. I can see that A is related to B, A is related to D, A is related to G. I can also see that B is related to D, B is related to G. So clearly B and A are the lower bounds of the subset BDG. I cannot take here D or G because D is not related to B. D is related to G, but it is not related to B. Similarly, G is not related to any of these elements from the subset BDG. So hence clearly I can see that A and B are two such elements which are related to all the elements of the subset T, that is BD and G. A is related to BD and G, B is also related to BD and G. As the lower bound of BDG are A and B, that means the set L consists of elements A and B. Now let us see that with what is the greatest lower bound. Here B is the greatest lower bound of BDG. Now clearly see that this set L consists of, or the set of lower bounds consists of elements A and B. So as per the definition, we have to find one such element to which all the remaining elements of the set L are connected or related. So I can clearly see B is one such element in the set L. Set L consists of elements A and B. So B is that element which is related, to which A is related, and of course B is related to itself. So I have to find such an arbitrary element to which all other remaining elements of the set L are related. So obviously if separate B, I can clearly see that A is that remaining element and A is related to B. Okay, so since A is related to B, so that means I can clearly say that B is the greatest lower bound of Bdg, because A is related to B and B is related to itself, but B is not related to A. So clearly B is the greatest lower bound of B, D and G. So this is how you can find out the greatest lower bounds and the lowest upper bounds in a poset through a hash diagram. This is it for today. Thank you for watching.